All right, people. Last example here of 6.6. I know we skipped over 2, and that was intentional. So, but the last one here, number 5, example 5. What is the solution to natural log x squared minus 16 equals natural log 6x? And as you guys can see, sure enough, we can never get away from them. We're bringing back quadratics. Classic Algebra 2. They will never, ever let you forget about how to factor, how to check, how to do good old quadratics. All right, so we got our original, and we have kind of two ways of thinking about this. One thing is the same idea like we said in example 1. If you have the base to some power equals the base to some other power, and the bases are the same, the powers must be the same. This is the same idea. If ln of something is equal to ln of something else, then the two somethings must be equal because ln is consistent. So this right here, I mean, the other way you can think about it is you can, if you raise both sides from a base of e, then they'll both cancel. But again, just if you take the ln of something and the ln of something else, and they're equal to two somethings. So we can easily just say, okay, well, based on the log property of equality, as one would say, our two sides have to be the same. So that means whatever's inside of the natural log has to be the same. And sure enough, we all know, how do we solve a quadratic? We need to get it equal to 0, and then we do our factoring. So what do we got? Minus 8 plus 2. So x is 8, or x is negative 2, but not so fast, right? Just like anything else, not so fast. Get out of here, email. No. Sorry about that. Just like anything else, not so fast. We got to check it. So we're going to come over here. We need to test now if these are extraneous. So let me use that word. We need to test. Okay. So let's test x equals 8. So we're going to do the ln of 8 squared minus 16. Does that equal ln of 6 times 8? And we really don't need to take natural log. Here's the thing, guys. Like, natural log, yes, you have a button in your calculator, but more so, we just want to make sure they look the same. So this is ln of 64 minus 16, and this is ln of 48. And 64 minus 16, sure enough, is 48. So now we can be convinced. So the thing is this doesn't matter if this is ln. This could be, this whole problem could have been like log base 7 of 48. As long as, like, we don't actually have to calculate this, but as long as you literally have the same thing on both sides, now you're like, all right, so it checks out. Okay, so this one checks out. So this is a solution. And let me just drop down here. So now we're going to test negative 2. So we'll do ln of, make sure you're putting this negative 2 in parentheses, minus 16 equals ln of 6 times negative 2. So we get the ln of 4 minus 16 equals the ln of negative 12. And sure enough, ln of negative 12 equals the ln of negative 12. Good, yes, awesome, not so fast. Joke is on you if you think this makes it a solution. It doesn't, because here's why. Here's why. And I think ln's not the best example to use. So let me make a side jump here, and just because ln has the same properties, but it's not always the best. Let me go back to this example, log base 7. So what if this was log base 7 of negative 12 on both sides? Remember that you need to ask yourselves, the base, like if we were trying to evaluate this, 7 to what power would give us negative 12? Because remember, when you do a log, you say the base to what power gives me my answer. Well, the thing is, guys, is that you can't raise a number to a power, any power, and get a negative answer. So this is not possible. So since taking the ln, and I mean, this goes for the same, guys. You're asking yourselves, e e to what power gives us negative 12, but it's just not as kind of readily apparent. And it's not possible. There is nothing that works. So negative 2, even though it makes the equation be ln of negative 12 equals ln of negative 12, which on paper it looks equal, we need to go back and think, well, wait a minute. A log is some base raised to what power would give us negative 12, and that's not possible. So for that reason, negative 2 is an extraneous solution.